So how do we manipulate a formula so that the required variable is the subject of the formula? Here the question says convert 25 degrees Celsius to Kelvin. The formula written there is very useful for answering this because capital T is what's required. So we simply substitute into the equation capital T equals 25, which is what the small t is, the temperature in degrees Celsius, plus 273, and the answer is 298 Kelvin. Remember to include the correct unit. But what about if we had to convert 500 Kelvin to degrees Celsius? Now this formula is not so good for answering this question because the subject of the equation is capital T, but we're not trying to find out capital T. We're trying to find out small t, in other words, the temperature in degrees Celsius. First principle, when you manipulate formulae, what you do to one side, do to the other side. And that keeps the equation true. What do I mean by this? Let's take a simple equation. 4 equals 2 plus 2. An equation, which includes formulae, which are a type of equation used to find out a particular variable. An equation consists of two things on either side of an equal sign, and the two things are the same as one another. So 4 is the same thing as 2 plus 2, of course. So that's why this equation is true. Now this equation remains true as long as whatever we do to one side, we also do to the other. When I say it remains true, I mean that still the thing on the right does equal the thing on the left. So I could say, for example, 4 plus 1 is equal to 2 plus 2 plus 1. That's still true. Now it's saying 5 equals 5. I could say 4 minus 3 is equal to 2 plus 2 minus 3, because now I'm saying 1 equals 1, which is true. I could multiply both sides by something like 2. 4 times 2 equals 2 plus 2 times 2. Now I'm saying 8 equals 8. Obviously, that's true. I could divide both sides by the same number, maybe by 4. 4 divided by 4 equals 2 plus 2 divided by 4. That's the same as saying 1 equals 1. So all of those things remain true because what's on the right-hand side of the equal sign and what's on the left-hand side of the equal sign are the same thing as one another. They're equal to one another. Next principle. You are allowed to swap the right and the left sides of the formula around. That's because if one thing equals the other thing, well then the other thing does equal the one thing. It doesn't matter in which order you write it. So for example, 3 does equal 2 plus 1, and so does 2 plus 1 equal 3. It doesn't matter that I've changed the order around. Capital T equals small t plus 273 is the same thing as small t plus 273 equals capital T. As I've already said, what you do to one side, you must do to the other side. So you might add or subtract a certain amount from both sides. Let's use these principles to manipulate this formula so that small t is the subject of the formula. So we subtract 273 from both sides. Capital T minus 273 is equal to small t plus 273 minus 273. We can see that on the right-hand side, the 273's cancel one another out to 0. So now we have capital T minus 273 is equal to small t. Remember that we can swap right and left-hand sides of the equation or formula, and so we have small t equals capital T minus 273. We have manipulated this formula to make small t the subject of the equation. And now it's very easy to answer this question. Convert 500 Kelvin to degrees Celsius. We've manipulated this formula to this format. Small t equals capital T minus 273. We substitute 500 into capital T and we get our answer 227 degrees Celsius. Let's manipulate this formula to make V initial the subject of the formula. We subtract A delta T from both sides. V final minus A delta T is equal to V initial plus A delta T minus A delta T. Those two A delta T's cancel out to become 0 because A delta T minus A delta T equals 0. Anything minus itself is 0. And so we don't even need to write plus 0, of course. So now we have V final minus A delta T is equal to V initial. We just swap right and left hand side so that V initial is on its own on the left hand side. It is now the subject of the formula. V initial equals V final minus A delta T. Remember that when you're manipulating a formula, what you do to one side, you must do to the other side of the equal sign. You might multiply or divide both sides by a certain variable or number, and another way of doing this is using a triangle. So let's say we need to manipulate V equals delta x divided by delta t. In other words, velocity equals displacement per time. And we want displacement, delta x, to be the subject of the formula. So we multiply both sides by delta t. That gives us V delta t is equal to delta x over delta t multiplied by delta t. That's the same as saying delta t divide by delta t times delta x. The delta t's cancel out because anything divided by itself is 1. So we have 1 times delta x, or just plain delta x, on the right-hand side of this equation, and that equals V delta t on the left-hand side. To make delta x alone on the left-hand side, all we need to do is swap the right and left-hand sides. And then we have delta x as the subject of the formula. Delta x equals V delta t. A quick sort of trick way of doing the same thing is using a triangle. V equals delta x over delta t can be written in a triangle form. You can see that delta x is at the top of the triangle, and then V and delta t are at the bottom of the triangle. And this makes it very easy to manipulate this formula. Delta x equals V times delta t. Delta t equals delta x divided by V. V equals delta x divided by delta t.